In addition to research on where attention is focused, whether it's on locations or objects, and whether it's a spotlight or not, there have been several different groups of theories on selective attention. And I want to talk about three of the main ones just because they illustrate some of the main problems that come up in that particular literature and kind of what the problem of attention actually is. So, the problem of attention is in some ways actually summarized in this picture right here, where you see this funnel and you can think of all the information from the outside coming in, and at some point that gets funneled and selected out so that only a little bit of information makes it through, and that's the information that's then further being processed. So the question is, how does that process exactly work, and at what point in the information processing stream does that actually take place? So in other words, how early does information get selected or excluded? And one way to study that is to figure out what kinds of people can actually, what kind of things people can actually attend to and what they can kind of simultaneously process and what kinds of information they can't, and then look at how early certain information may be dropped from the attentional processing. If you want to think about when this can happen, this is in some ways kind of lame, but you could either theorize that the attentional filter happens right at the get-go, so that information that comes in is some of it is filtered out right away and is not processed further at all. Then there's the possibility that most of it is filtered out, but some of it can still make it through at some minimal level of processing, which would be called attenuation theory. And then there are theories of selective attention that claim that actually everything makes it through to the attentional system. Then it's all processed, and only at the point when we're going to give a response is it the case that one thing is selected and the other things are selected out. So how can we distinguish between these possibilities? And let me just show you another diagram that kind of shows how this may work. Right? So the idea is information comes in. Let's say there's two streams of information. Let's say two people talking to you, and you're only trying to attend to one and ignore the other. One possibility is that right at the get-go, you can actually manage to ignore one of the two streams and only attend to the other stream. So this gets knocked out right away. The other stream goes for meaningful processing, and then your response is based on that. Attenuation is more something like this, where the attended message makes it all the way through. The unattended message does get processed at a sensory level, but then as soon as you get to really meaningful processing, most of it is actually still dropped, and your response is barely influenced by it. Late selection is the case where, here on the bottom, both streams are fully processed at a sensory level, even for their meaning, and only when you respond do you select one or the other. Now we can ask, how do you study this, and how can you figure out which one of these possibilities is more plausible? Well, for this, they have designed a task that's called the dichotic listening task. So di meaning two things, right? Dichotic listening, what happens in those tasks is that imagine that you're wearing headphones, and on one side of your headphones, or on one ear you hear one stream of sound, and on the other side you hear another stream of sound. You're then being told to just attend to one of the two and ignore the other, and then you're basically told that you need to repeat what's heard, for example, just in your right ear, and completely ignore what's being said in the left ear. So the question then is, how much information from the unattended channel still makes it through and people end up kind of incorrectly reporting anyways? And that would give you some idea about early versus late processing. According to early processing, none of the unattended streams should make it through. According to late processing, most of it should make it through. And attenuation, again, is somewhere in the middle. So I'm going to play you a clip just so you can hear what this kind of task sounds like. And it will sound like gibberish kind of, but it's two different speech streams on top of each other.
Although a limited number of merchants, large landowners, and traditional hereditary elites undoubtedly prospered under the umbrella of the expanding imperialist economic order, the majority of people, urban and rural alike, suffered considerable hardship as a result of the policies adopted by their forerunners. The effects of the Industrial Revolution on the poor had been felt in Europe too, but there
So you get the idea, it's quite annoying, but one message that was probably the one that people were told to attend to was all about the Industrial Revolution. And then the other speech streams sometimes threw in words that had maybe something to do with, characteristics of leadership, like charismatic at some point made it through in my listening to that. You're supposed to ignore that, but the fact that I picked up at least one of them means that complete early selection didn't actually really work in that context. So let's go through these possibilities and how people came to first claim early selection and then what sort of was tweaked and where we are now. So early filter theory was developed by a British psychologist by the name of Donald Broadbent, and he developed this task really to study attention. And he would do simple things like, have a person on one side of the participant read out one set of numbers like 8, 6, 9, 1, 4, and then another person on the other side read out the other set of numbers 5, 3, 2, 7, 1, and then people were told to either recall one or the other. And he was basically studying how well people could ignore this irrelevant set of numbers that was played to the unattended ear, and if they were able to do so. Now, he found that people were actually really quite good at this, and at least with these numbers, they didn't really mess up. They would either report 86914 or 53276, but they wouldn't say like 83974, where they were switching back and forth between the two ears. So he took that as evidence for early selection. An early problem of early selection is this phenomenon that's called the cocktail party effect. And if you've been to a party, you might have experienced this, where you're trying to talk to somebody, and there's all this background noise, other people talking, dancing, music, and so forth, and you think you're not really attending to any of that until, in a conversation next to you, you hear somebody dropping your name. Now, typically, people pick this up immediately, even though they were not attending to that particular speech stream. From the perspective of early selection, that's problematic, because it should be that you selected out not to attend to that conversation. It's only the conversation you're actually in yourself is what you're attending to. Yet, personally relevant information like your name will still make it through, and you will actually that will be picked up by your attentional system anyways. So that is a problem for early selection. So again, just a personally meaningful information could be your name, could be your hometown, could be your university that you go through, things like that you would still pick up in the background. Now, even Broadbent's students managed to demonstrate that early selection was actually not quite right. So if you modify the test that they laid out, and now rather than numbers, you have one side of a person be read to, and it reads, "Dear looked Sally D. R. Glass," and the other side says, "Alice aunt through how looking you." People ended up reporting, "Dear Aunt Sally, how are you?" or "Alice looked through the looking glass." So in other words, they would extract from this unattended channel information that was sort of semantically relevant, that made sense in the context of the sentence that was being processed. And rather than completely ignoring one stream, they would actually pick up information and come up with some sort of coherent thing that they would hear, that had some meaning to it. So again, that was also a problem for early selection. Early selection doesn't really seem to hold. So what do people notice in the unattended channel? Well, a couple of things. First of all, people can actually tell you what kind of physical characteristics the sound has. So they can tell you, there was some sound. Was it speech? Was it noise? Was it a female voice? Was it a male voice? But they can't actually notice things like whether it's actual speech versus nonsense speech, whether it changes from maybe English in the beginning and then German later on, or Dutch or whatever. And sometimes they couldn't even tell what the word was, even though the same word was repeated in the unattended speech stream over and over and over. So in other words, unless it's somehow semantically relevant, people can actually fail to notice pretty substantial things in the unattended channel, which again speaks to our ability to direct selective attention. But overall, these data do seem to argue against early selection. Anything that's personally relevant certainly still makes it through to more attentional processing. The attenuation model then was developed by Ann Treisman, and again, don't worry about the names too much, but if you want to look into this. The claim she made, which in some ways this is kind of like, okay, sure, some stuff makes it true type of theory. Attention doesn't completely block out the unattended ear, but it attenuates it, meaning we're not fully paying attention, but there's still something that's being processed. And as long as it reaches some sort of threshold of recognition, it will still make it through to the attentional system. Now, if you think of your own name, the claim would then be that your own name you've heard so many times, and it's personally so relevant, that for you to hear your own name, that name has a lower threshold of recognition. It takes very little sound information for you to recognize your own name because you've heard it so many times. So the idea behind this attenuation idea is that as long as something has a fairly low threshold for recognition, it will still make it through, even if it's in the unattended speech stream. Now, if you think of that sentence, dear Aunt Sally this and that, how are you, right? There, some of these later words will have a lower threshold for recognition because they make sense given the earlier words in that sentence. So sometimes the sentence context will actually lower the recognition threshold for words that would logically follow it. According to this attenuation model then too, in line with this, right, several inputs can be processed at the same time, and selective attention has to happen at some sort of low level of semantic processing, semantic being another word for meaningful, based on its meaning. Now, issues with attenuation theory is that, of course, we're kind of saying, well, what does attention do actually then? So in the theory, all the channels of information are analyzed somehow, both based on their physical characteristics as well as based on their meaning. And if it's meaningfully so relevant, right, it has meaning for you, then all of a sudden it makes it through. So the question then that you're left with is, well, if that's the case, then what exactly is it that attention is even doing? We're still processing everything. How is that not almost like a late selection model? Again, late selection would actually claim that all information, all the sensory input, right, everything you hear is being processed before you make any selection about what you're going to respond to. So the filter in that case would be placed very late in the information processing stream, right before you make a response. Now, there's some mixed evidence for this, because, for example, meaning of words for the unattended message can be processed, like we already saw. But on the other hand, people cannot perfectly attend to both streams at the same time, right? It is still very difficult to listen to two conversations at the same time and perfectly repeat exactly what was being said. So this gives you an idea, though, of sort of the question of attention, and specifically selective attention, where it's all about when is stuff being sorted out. And we'll move on from there and look at some more up-to-date models of attention that deal with this whole question a little bit differently in the next video.